On an average,
Oh
on
God.
an on an average, now it's still how many days it is going for? How many days?
Next next 2 weeks will be there.
Whole
Yeah,
course for the course, sir.
yeah. Next 2 weeks, I'm going to close it.
Okay,
There is
means
only two topic is left. One is for Jenkins, one is for monitoring.
okay, within these 2 weeks, you are going to complete even the project also, sir.
Yeah.
Okay, sir.
Do you want me to do it very quickly?
No, sir, no, sir.
It is not possible.
Sir, take it more time also, sir. I'm okay with it. The more we take time, the more I can learn it, sir.
Exactly, because I cannot skip anywhere on this, especially for the Kubernetes. Okay, so that is the most
Sir,
focused.
frankly to say, the hands-on which I've done on pods,
Hmm.
clusters, I'm not yet perfect, sir. I'm just having a clear, but
No,
I've still practice.
so try to do the answer. Okay, you will get the doubts while doing the answer only. You'll get a lot of doubts. Okay, till you start, you will not get anything. For example, let me talk about one topic for part, right? Okay, if you are not started, what it will happen? The theory concept will be same. Okay, but what about the practice? The command, right? So you will not able to understand what is the command you need to enter it. Okay, and if you wanted to deploy it, also what is the command and how to see the logs of that uh, logs, right? So while starting only, you will get to know. Okay, so try to start so that you'll get a lot of doubts. Okay, till you are if you are not started, I mean, after 1 week or 2 weeks, if you started, you will forget the theory also. What is the topic? Again, you need to come back to that video, you need to see it. See, to see the session videos, sometimes it takes time. Minimum, you should have a 1 hour time, right?
So,
1 hour, you should watch the recording. Again, you need to write it down. If you write it down, that is well and good. If you are not written, just all the concept, if you are observed it, then you can try to do it. My recommendation, I know it from the freshers, it is not possible to remember all the topics, but main topic, Kubernetes. Okay, Kubernetes means what is this Kubernetes, how to install it, how to set up it. Okay, first learn it, installation, and the topic of theory. Then go for it later. So all the topics you need how to install it. That is the main thing. Okay. So if you are not able to install it, that is a first basic only, right? Just copy
yeah.
and paste it from the my notes. Sometimes you will face the issues also, my notes also. If the outdated commands, obviously you will get error.
Yes,
Okay,
sir.
how to upgrade it? Okay, these it will come. You need to do the daily answer. At least you need to spend minimum 3 hours per day.
Yes, sir.
Any topic you take it, any of the one topic you take it and try to do it. See now what I will do, I have a notes. Okay, that's fine. Okay, if I wanted to write it down, okay, again I need to refer the official documentation to go to that official documentation to tell you how much time it will take it, right? So that will too much, it will take too much time. I need to refer the documentation, then I need to tell, and I don't want to skip the steps also, right? All the a topic should be covered it. Okay, now sometimes I will add other than the course also, I'm going to add the other topic also where we we should not miss it, right? Many topics I covered it. Okay, so that's fine. Okay, my request is do the answer, you will get the yes errors, I'm sure. If you are not started, you should start. get the issue, get the errors. My recommendation to get the errors, then only we learn it. If you're not getting any error, just copy paste it. No. Okay, somewhere you will do the some issues. The errors automatically it will come. If we one step if we are not executed, then you'll get the error. Then you will go and you will see that what is that error. Chalo. So before going to that storage pending topic, did you created the cluster using the Terraform and use the any playground to create the pods?
Sir, using Terraform, I did the cluster, sir.
Yeah.
Playground, I did not.
Sorry, playground you can test it out anytime. That's not a problem. But at least you are able to create
Using
the cluster.
Terraform. Yes, yes, madam.
Now what I'll do? Let's go to namespace. So let's talk about namespaces. So what is namespace? Why we require namespace? What are the types? The architecture diagram and diagrams. We'll go through the first theory and we'll jump into the answer. So what is a Kubernetes namespaces? So a namespace is a virtual cluster inside the Kubernetes cluster. It provides the mechanism to partitions the cluster resource into the isolated groups, giving the different teams, project or environment their own dedicated space while sharing the same underlying hardware. So let me explain it one more time. So namespaces, it is kind of a virtual cluster. So normally we are creating a one cluster, right? So each cluster we can able to create the namespaces and we can able to segregate it. For example, every company there is a productions, staging, dev or QA. Three environment will be there, right? So one cluster we can able to make it as a three environment using the virtual clusters. How we can able to do it? Using the namespaces, we can able to create it. But normally namespace, everybody they will call it as a virtual clusters only. Okay. One single cluster or one physical Kubernetes cluster. Inside that it is going to be segregate as a virtual. Okay. So that means you will get the isolated also. Okay. If you are created a environment of production, there is no connectivity on the staging also. Okay. Staging also there is no connectivity for dev. So it is kind of a virtual cluster. Okay. No need to create a multiple clusters. For example, different applications, different projects, you can able to create it. Okay. The next one is the resource isolation. So each namespaces is a isolated scope for the names. Same pod name can be exist in the different namespaces. Access control, RBAC policy are the namespaces scoped. Teams only see and their own resource. So what we can do, we can create the namespace. Only particular team can able to access it. A resource quota. Normally we have a resource quota, right? CPU memory we can able to assign to that namespace only those parts it will go and it will use only the dedicated what we are mentioned those CPU memory only it will use it. And multi-tenancy means multiple teams or the environment dev staging prod share one cluster safety. So think of namespace like a your floor of the building. Team shares the same building clusters but have their own floors like with separate logs, budget rules, or floors, first floor, second floor, third floor, right? Same thing. You got it?
Sir.
Namespace is a virtual cluster. Uh, you can just, I mean, you can just imagine that how virtual cluster will be there. For example, I told you, right? You can just take it your home. There is a first floor, second floor, third floor, right? Same thing here also in the name in the Kubernetes also. So in a single physical cluster, there is a multiple virtual namespaces, we are going to create it. So without namespaces, with namespaces. So why do we need this namespace, right? So without namespaces means all resource share the one flat space called name collision inevitable. Any team can accidentally delete or modify another team's resource. One run away app can consume all the cluster CPU or memory. No way to separate the dev staging prod in the same clusters. kubectl gets flooded and all resources from the all teams visible. So this is a challenges without namespace. After namespaces segregated, same name front end can exist in the dev also, right? Staging or prod simultaneously. So multiple environment we can give it front end or back end anything. Okay. And RBAC scope per namespace. Team A cannot touch Team B's resource. Resource quota cap, right? CPU, memory, object count per namespace. Dedicated namespaces per environment and shared infrastructure. QCTL-N. Team A only shows the team resources. Okay, so it is not going to be shows another resource also. So built-in Kubernetes namespaces. So there is a default kube system, kube public, kube node list. So these are all the default namespaces comes from when you create the Kubernetes clusters, right? So by default, all pods it is going to be created on the default only. Okay. So use personal project, quick demos, simple single clusters. So kube system pods only. Do not deploy user workloads here. Do not deploy anything on this. Kube public exposing the cluster discovery information to the unauthenticated clients. And kube node list internal audit mechanism for the user resources. So I'll show it to you how many namespaces by default it will be there.
Okay.
Namespaces internal architecture. So if you are creating this is entire your cluster, you have a namespace for development, staging, and production. So inside that you can have a deployment, services, config, okay, all the things, secrets, okay, HPA. So anything, any resource can able to create it, okay, and resource quota and RBAC. So each namespace we can able to apply it all the RBAC or quotas or services we can able to create it, deployment, secrets, config, anything we can able to do it. But there is no communication between the these environments. Okay.
Yes,
And,
sir.
and how namespaces runs in the Kubernetes cluster. So if you're able to see it, example I have taken worker node 1, worker node 2. So worker node 1 pod it is creating a namespace development, right? So here is a IP address and pod for production and Nginx pod IP address. Pod again, worker node staging, here is IP address, right? So pod for the productions, here is an example. Okay. So this is how uh, the namespaces also it will create and each node, your pod also it is going to be created. So top up your namespaces only, your pods it is going to be run. So pods from the different namespace run side by side on the same node, isolated, logically shared the physical. So this is a physical only, but inside it is going to be created a virtual. So this is about how namespace runs in the Kubernetes cluster nodes. And advantages of your Kubernetes namespace, logical resource isolation, resource quota, and multi-environment on one cluster, RBAC access controller, cost allocation, and clean operational scope. Disadvantage is so not true isolation. Namespaces are logically boundaries only. Nodes, kernel, and network hardware are still shared. So a noisy neighbor or the kernel exploit can affect to the whole cluster. Okay, there is some disadvantage, right? So there is no issue with the port side or namespace. There is an issue with the nodes. Okay, so cross namespace communication complexity. If you wanted to some of the people, they will ask you that namespace communication also. That is not possible, right? So service in the different namespace must use fully qualified domain namespaces network policy to control the cross namespace traffic at the configuration over it. So not a secondary security boundary and cluster scoped resource and operational overhead namespace sprawl. Okay.
So,
So these are all the disadvantages of your namespaces, right? Some of the things they don't want to implement. For example, cross namespaces, right? It is not possible. And so without governance, namespace multiply unchecked up-down namespaces, consume the quota, and create a audit confusion. So there is a lot of things are there. Okay? Those things it is not possible. So that is all about the namespaces. So here, if you're able to see it, so what is the difference between the namespaces versus other isolation? Okay, so left side, all the features it is available, and here if you're using a namespaces and separate clusters or virtual cluster. So separate cluster means you can say that your physical cluster. Virtual cluster means you can take it as a EKS clusters. So here if you have created a namespace, it is a logical, shared, and scoped via RBAC, weak, and resource quota, low, and simple Teams environment. And if you have a separate clusters, it will be the security will be strong. Remaining, if you go one by one, it is very strong. So within a cluster is good, outside cluster is good. Is okay. So uh, physical hardware is good because if you're able to see it, this is going to be separate the nodes. Physical separate the nodes. It is not going to be shared anything. Virtual cluster also it is a danger, right? Because it is sharing the your resource of the nodes. So each one there is a difference. Within cluster is good. If you wanted to create a multiple cluster each environment, that is also good. But most of the people they will use namespaces. Okay, so that is all about the namespaces. Do you have any question before going to the answer? Any question?
no, sir, not for me.
Okay, let me go to that cluster. Okay, now we are able to see the kubectl
No, sir.
get nodes. Now kubectl get all namespaces. Sorry. Well, let me clear it. Let's use it kubectl get ns. Yeah, that's fine. We can able to use it anyone. Name spaces. So the short form is NS, and full you can able to use it. Are you able to see it? The default node release, queue public, queue system. So these are all the default namespaces in the Kubernetes clusters.
Means those are the
Default one. Okay.
default names.
Yeah. When you create a Kubernetes cluster, this will be created. And so I told you, right? So first one is, so we are going to use the default one always. Okay. When you create any pods, if you are not mentioned any namespace, by default it will be created. Okay.
Okay.
Now what I will do, I'll create the namespaces. Okay. Let's do it. So I'll start from the some few namespaces. I'm going to create it different environment. Okay. So there is a two way to create it for the namespaces. The easy way is obviously command line interface, right? kubectl. So this is a simple way to create it. So this will be created your namespaces. Are you able to see it? There is a test,
Yes, sir.
and same thing you can able to create a QA also and verify it. And if you wanted to create a productions, so I'm going to create a productions. So multiple way you can able to create the namespace, but I'm using the kubectl because very quickly you can able to do it. Otherwise, you can write a YAML file and do it. Okay. So now what I will do, let's create a one application. Okay. So VA name deploy dot YAML. I'll just explain it. So let me explain it. What is this namespace deploy? What is there? Cat. So if you're able to see it, I'm trying to deploy I'm doing the deployment. So I'll start from the API versions. Kind is deployment. Metadata, I'm going to use it. My app deployment. Are you able to see it? There is a namespace called production. So if we are not mentioned this production, this will be created on default. Okay.
Okay.
And labels, I'm going to use a tab, my app. Under the spec, I'm going to use a three uh, replicas, and it is going to be match it. This is my pod template labels, and under that we have a spec, right? Under that we have one more spec for the containers. And if you come down services also, I'm going to create it. In each single file, you can able to create a multiple, or you can create it many, but you need to mention this hyphen when you start new YAML file. Okay. And this is a service, right? API version v1 service metadata namespace, and namespace for service also I'm going to use it, because without namespaces if you apply it you'll get a error. Okay. And these are all the, we know it already, I have already explained it. This is going to be exposed on the load balancer, right? Now let me clear it. kubectl apply -f namespace deploy. Okay. Now if you type it kubectl get namespace, so there is a production, right? Now Let me verify it. Right. If I type it kubectl get pods, are you able to see it any pods? Because no resource found in the default resource. So for that, what you need to do? -n. What is the name of the your namespace? Just copy -n, mention it, just paste it. Are you able to see it now? If you type it kubectl get deploy also, you will not see. Again, you need to use name spaces. Okay, and service also. So we are able to see the load balancer. Let's access the application. Any doubt till now? Let me.
Sure.
So again, if you wanted to deploy onto the development, okay, just do the namespace ls cat. So you just change to staging or development, and here both side you need to change it. One is from the deployment, one is, then you can try to do it. Okay, so that you will
Okay,
get
sir.
it. So now let me verify that our application is up. Okay, are you able to see it? There is a default Nginx website. Okay,
Sir.
so this is all topic about your namespace. Any questions? So tomorrow assignment is create a development namespace and deploy the application exposed to load publicly or load balance. Okay, the simple. Only you need to change the namespace for development and try to do it. So now let's move on to that storage topic. So what is this Kubernetes storage? Volumes, PV, PVC, storage classes, CSI driver, architecture. So let me talk about one by one. So what is Kubernetes storage in the AWS? Or you can call it as a what is EKS storage? Because Kubernetes storage means it will comes entire thing, right? So we'll I'll talk about EK storage and Kubernetes both, because it is a both. Some of the few services are common, but when you come to cloud, it will be more. So the services, if you are using a Kubernetes, we have a few. I'll show it to you what all the storages are Kubernetes default one, and EKS is what is that. So Kubernetes storage is a mechanism that provides the persistent and shared or ephemeral data to container running on the pods. Since pods are ephemeral, once you delete it, data will be lost, right? So Kubernetes, what it will do, provides the abstraction volumes, persistence volume PV, persistence volume claim PVC, and storage classes to decouple the data lifecycle from the pod. See, normally the pods will be stored under the cluster. I mean, inside the pod only, your container data, everything it is going to be shared, right? If someone is deleted your pod, what it will happen? The data will be lost, right? So
Yes.
that is a problem. So containers have ephemeral file system. If they kill the pod, all data inside the container is permanently lost. So for example, databases logs, user files, all gone. To solve, so we are going to use the volumes. So what is this volume? It is a ephemeral, a durable storage attached to the pod. Many types are available. And persistence volume, we are going to use it because cluster-wide storage resource provisioned by the admin or dynamically by the CSI. So anyone persistence volume, they will create it. Provisioned means they will create it by the admin or dynamically by using the CSI driver, we can able to use it. And PVC, so user going to store as a request. So user what it will do, I need 1 GB or 10 GB, 20 GB. User will be request the storage. So PVC what it will do, it will binds to the matching PV, abstract the backend details and it will give the storage capacity. And storage classes what it will do, it will define the storage profile. It can be created as speed, tire, reclaim policy, provisioner. I mean, what is provisioner means? It is a EBS or what or GCP, anything. Okay, that it will decided by your storage classes. So main thing is you should know volume, persistence volume, PVC, storage classes.
Storage.
And so without persistence storage with Kubernetes storage. So if the pod is crashed, database wiped, all records lost permanently. Scaling they creates the new pods. Each has its own isolated data isolated. I mean, each pod when you are creating its own isolated. Okay, and dev must be manually provisioning because NFS or disk on the every deploy. Container rates to overlay FS IO performance is terribly. Moving app between clouds requires storage refactoring. And with Kubernetes storage, what it is happening, so we can able to persistent the volume services, services pod restarts, crashes or rescheduling. So if the pod has been restart and crashes and rescheduling, if anything happen, your persistent volume will be same. That means it is not going to be deleted. So shared volume allows the multiple pods to read write the same dataset. So multiple pods also can able to share the your volumes. And storage classes auto provisioned cloud discuss and the PV's creations. Direct block storage, it will mount to or bypass the overlay FSS for the full native speed. So here we are going to use a CSI driver abstraction swap backend without changing the app YAML file. So you don't want to change it. So the CSI driver automatically it will abstract it. So this is all about the without s- persistent storage with Kubernetes storage and Kubernetes volume types. So if you're able to see it, MTDIR. Okay. So this is a pod lifetime. Till pod, your empty directory will be available. So created when pod starts, deleted when the pod dies. Shared between the all containers in the pod, useful for the temporary data caches, scratch spaces. Okay, this is a Kubernetes one of the type. And host path also. Host path, what it will do? Mounts the file or the directory from the host node into that pod. Data persists across the pod restart also on the same node. If risk is if the breaks on the rescheduling, obviously this is also it will be deleted. And config map or secret also you can able to save it. Okay. So where inject the configuration or the secrets as the files or the environment variables, not for the large data. Backed by the SCD, automatically update when the config map changes. So this is related to the I mean one of the separate services config and secret. If you wanted to store the secrets, everything, we can able to keep it in the secrets or config map. So here also we can able to use it to get the secrets inside the your pod also. And let me come to persistence volume claim, that is PVC. This is a standard way to request the durable storage. Binds to the PV. Data persists across the pod deletion. Backed can be NFS or cloud disk or anything. Okay. So where all we can able to use it? Database, user upload, stateful apps. So NFS, obviously, it is a network file system mounted into the pods. Multiple pods can read write the same NFS here simultaneously. Good for the shared storage across the nodes. So we can able to use it shared file storage, CMS media files. Then we can able to use it. CSI volume. So this is the main in the Kubernetes cluster. So what this CSI volume it will do? It will container storage interface. CSI means standard plugin APIs, AWS EBC, GCP for PD, and Azure Disk, Ceph, Portworx. So there is a multiple CSI drivers are there. So this is going to be enable the dynamic provisioning. So now most of the companies
Sir,
are
what is this? What is this provisioning?
provisioning means it is a creating. Okay. So automatically it will create it. Enable the dynamic provisioning means it will create. So in the technically they will call it as a provisioning. Okay. So that is all about the provisioning, and CSI volume means we can able to use it multi-cloud, each their storage one. If it is AWS EBS, if it is GCP persistence disk, Azure for Azure disk. Okay. So now we are trying to use this one because if you are comparing all this, okay, the good one is CSI, right? So there is no dependency, nothing. Okay. So make sure that you should know how to create this CSI volume, how to uh, what is this PV, PVC, storage classes, everything you should know. So I've already mentioned where all you can able to use it, which volume type, and so how the object hierarchy for your storage classes. So we need to write a storage classes. If you're able to see it, provisioning and provisioner both are different. See here, it is showing provisioner. That means are you the AWS, are you the GCP guy, are you the GCP Azure? So here we are using a EBS CSI driver. And reclaim policy, we need to mention it. Volume binding, wait for the first consumer. So if we mention it, we are going to create a one YAML file. Then we are going to define the PV, what is the capacity, access nodes, storage classes, okay, status, volume bound. This is what we will write it down. Then we will write a one more YAML file for PVC. So this is going to be mentioned the pod. Okay, that means what is a storage, it should be bind it. And so once all this done, our pod it is going to be created on here. So pod will be created. It will be taken the data from the your persistent storage. How much data I required, everything it will get it from here. And here access modes means read write once. ROX means read only many. Read write many. RWX. RWOP means read write once in the pod. Okay. So this is a hierarchy of your storage classes and how it is working uh, your storage also. How it is the pod it is getting the data from the your persistence. Well, I'll show it you this in the demo only so that you will get to know. So here is a how storage runs in the Kubernetes clusters. So worker node one, if you're able to see it, kubelet plus CSI node plugins should be installed. It. So pod A, you will have a Postgres, okay, and Postgres default path is here, the mount point. Now what they are using? They are using PVC to store the data. So here pod B, they are trying to use it empty directory, okay, and pod C config maps. And pod D, they're using a PVS also or NFS also. So multiple the types of we can able to use it each nodes. Okay, but this is not the right way, but I'm just showing here which are the one we can able to use it. Okay, so cloud storage for the backend, we are going to use it AWS EBS, empty directory, node RAM, config maps, SCD backup, NFS server for shared. So my recommendation or the outside the recommendation, obviously we should use their cloud providers EBS volumes. It can be any name. The name will be different, but we should use it their storage. And here dynamic provisioning, how it will happen. So we are going to define the storage classes, and user creates a PVC, and the CSI provisions the PV, and PV binds to PVC. Then pod, it is going to be mounted your PVC. So this is how flow it is running, or how the pod getting the data. So next one is container storage interface architecture. So Kubernetes core architecture here, CSI interface here is, for example, create a volume, delete a volume, control the publish volume, node stage, node publish volumes, everything CSI interface. And plugins are here. So these are all the plugins for each provider. For example, AWS, they are using a EBS CSI. Under that, there is a GPT, GPT-3, many things are. GCP they are using, Azure they are using, and Ceph, okay, and Langrom, okay. These are all I mean, cloud providers plugins. So advantages also it is available. Data persistence beyond the pod life cycle, decoupled storage, cloud agnostic via CSI, dynamic auto provisioning, multiple access modes, flexible reclaim policy, and disadvantages means complex configuration like PV, PVC, storage classes plus volumes. So this is the one complex I have seen it ever. Volume expansion, snapshot and backup complexity. This is also it is remote maybe because we can able to take the backup, not snapshot. RDFlex support is limited. Performance override, stateful set required for the stable modes. This also we can able to use it. Stateful set. Any questions till now?
Was it?
Okay. Now we'll talk about storage types with the comparison table also. I've already explained it. Futures, empty directory, host path, PV, PVC, NFS, and CSI cloud. So these are all the comparison table. You choose it anyone. You just go through this slide, and which is the one good is for me it is a CSI cloud. Okay, you just verify it all the futures and let me know tomorrow. So for today's session I will be using CSI cloud only. So that is all about the storage presentation with tail. Any doubts?
Yes, sir. Was it?
Okay, so let me go to clear. Let me, so to implement uh, for Kubernetes storage, we need to add one of the policy. Okay, so we have already created the cluster, right? Just select any one of the node and come down below. There is a policy name. See, there is a policy name, right? IAM role, right? Just open it. Okay. So here there is no policy. I'm going to add the policy name called EBS driver. So why I'm adding this one? Because we are going to use a CSI, right? EBS CSI. So that is the reason I'm going to select it policy 1, policy 2 versions also. This is the first things you should know it. Okay. Then
Means like for the latest version.
Yeah, latest version you can able to use it. Anyone is fine. Okay, but use it latest policy v2 only. Now I wanted to create the add-ons called our EBS, right? So let me, so there is a two-way. One is from command line, one is from the portal side also. Okay, if you go to that Kubernetes services, go inside the clusters, go to add-ons. See, there is add-ons right here. So by default, it is already enabled so that I don't want it to do it. If you need more CSI driver to be installed, just get more add-ons. There is a lot of add-ons out there. Okay. So now I don't want it to install it. Let me see it from the command line interface. CSI, it is enabled or not. Okay. So we need to install the EKSCTL, right? Let me get started. Install EKSCTL. So once it is installation, just verify it. So it is saying, okay, namespace is different, right? Let me copy this. You need to change the cluster name.
So cluster name, everything.
We should mention the cluster name here. Otherwise, how if there is a 10 cluster, how it will get to know the EBS is enabled, right? So here it is already active, and we can able to verify it one more way also using daemon sets. Okay, so it will show us backend how many it is running. If you're able to see it, three decide. Okay, because three why it is running means three nodes are there. Three nodes it is going to be created. Now let's create the storage YAML file. Now what I will do, let's use nano. Okay, so it is already there. Okay, so I'm going to create the API versions, storage classes, and kind storage class, and metadata and name. I'm going to use it EBS-SC, and provisioner I'm going to use it EBS, and wait for the first consumer. Wait for the first consumer means anyone should be created the pod. Okay, now let me apply it. Okay, it is created. So how to verify it? Storage classes are created or not? So there is a short storage classes here. Name you can able to use it. SC also maybe. Sorry. So the storage classes it is created. So we can able to describe it also. So you will see that all the details. Okay. Now let's create a PVC, right? Nano PVC.ml. But the thing is here, you need to write it down every resource. You need to write a YAML file. Now qctl apply -f PVC. Okay, once it is created, so you can verify it. So it is saying still it is pending. And now let's create the PV, sorry, the pod. So now if you're able to see it, we have created a,
Storage.
okay. So now we have created a storage classes, and other one, which is the one we have created, we have created a persistence volume claim. That means PVC we have created. So PV we have not created, right? So let's do it. So now if we are able to see it, PVC, it is showing pending, and PV, it will not show anything. Okay. Now what I will do, I will not create any PV. So directly I'm creating the pod. So in the pod only I'm going to mention the PV details, right? So nano uh, pod, sorry, let me use it. A storage pod or PV. So what I am trying to do here, I am trying to create the pod, API version pod.
Pod.
Metadata, I'm
Yes.
going to use it name of the pod, and spec, I'm going to use the containers. So Ubuntu image, I'm going to use it. And if you're able to see it, so every 5 second, I mean, we need output.txt file should be generated after 5 minutes. Okay. So the date and time, it should be echo. That means I'm just mentioning the comma argument. So here, volume mounts, if you're able to see it, so I'm going to use the persistent storage, and the mount path I'm mentioning data, and volumes, under the volumes I'm going to mention it as a volume name called persistent storage, and the persistence volume claim I'm going to do it. Claim name called claim name. So this is already it is in the place in the your PVC only. So these three data you will get it from the previous YAML file, right? So one by one, if you created only, you will get to know, right? So this PVC PV you will not able to see it in the Kubernetes official doc. You will get it from the EKS official documentation. That is the one thing you should know. Now, if you are able to see it, uh, PV, we are not able to see it because I'll tell you why. Sorry. And PVC, still it is showing pending. Why it is showing pending means, so we need to create the pod. Till now, it will not shows any data. So now what I will do, I'll create the pod. kubectl apply -f. Now verify the PVC. Are you able to see it? Pending to, it is changed to bound, right? And
Sir,
PV also.
Kubernetes, sorry, kubectl get PVC port.
So kubectl get PVC, it will show us the EBS claim volume. Earlier it was pending, now it is bounded to your volume.
I'm asking what is this command is going to do, sir?
This will get the just the output. Okay. So it is bounding to
Output
the
of.
output of EBS, I mean PVC volume.
That's it. Okay, sir.
And this is PV persistence volume. So this is a persistence volume. Now earlier we are not able to see it, right? This PV persistence volume name. So now we are able to see it after created the pods only. See, so there is a inter connected with your pod to your PV and PVC. And we can able to describe the PV also. Okay, what is there in the PV? So this is the details about your persistence volume.
Yes, sir.
So now let's verify the persistence data. So now we need to verify that the data is generating or not, right? So now we have created the app name, right? Now what I will do, without logging to that pod, I am doing the checking the output. Okay. Are you able to see it? The date and time it is generating as per the pod, right? So now what we can do, we are getting a data, right? Now we'll delete the pod. We'll see that the data is showing or not. Okay, now what I will do, I'll delete it. I'll delete this pod ML file. I'll create a new one. Kubernetes delete. Let's now what we can do, let's create a one more pod. So nano PV pod 1.ml. So I'm going to use the same, what is that? The volume name and storage. It should be same only. I'm just changing the name of the image only because I wanted to see that the data is available or not. So kubectl apply -f PV pod. Now kubectl get pod, right? So it is running, right? Now without login, let's verify some of the few things. So we have created a slash data, right? In the pod we have mentioned, right? So slash data, it is mounted to your pod. Now I wanted to see inside that what is there. So how to make it ls, right? We need to use here. Are you able to see it out.txt file? Now let me print this. What is there? We should get the date and time, right? See, it is stored in the slash data so that we can able to get all the data. So if you wanted to create a one more file inside here, yes, you can use a touch command to inside it and verify the data. All data, whatever it is showing here. Let's clear it. See, you will able to see it output.txt and test.txt. So you'll see the all the data, right? Any questions about this storage? If there is no questions, we can wind up the session,
No, sir.
right?
That's clear. Just do your answer and I'll come back.
Okay. So now I'm going to show it to you. The last one is you can try it on from offline. So now if you're able to see it, our cluster, it is showing end of support, right? And there is a 1.29. So what is the version now as of now? Kubernetes version. Okay. So it is almost all V 1.36, right? Can we upgrade it to directly 1.29 to 1.36? No. So you need to upgrade it 1.29 to 1.30. Okay. So here also it is showing update now. You need to make it 1.3. So how to do it? Using the Terraform, right? So normally manually nobody will not accept it. Okay. So what you can do, let's go to Cloud Shell. Just edit this main dot nano main dot tf. So here if you come down, there is a name called version. They've already defined it 1.29, right? Where is it? Are you able to see it? Cluster version. Make it 1.30. Then what you can do? Terraform apply. So this will just upgrade the your cluster. Okay, if you're able to see it, it is just refreshing everywhere. Okay, so it is changing to 1.29 to 1.30. This is the one you can do it offline. This will take minimum 30 minutes time. Okay, so try it and let me know. So I'm going to just hit enter. Okay, so try it and let me know the output. So let's find out for the
Yes.
today's session. And if you're while upgrading also, your application will be up only because backend it is running your uh, uh, one by one it is going to be updated your node also, cluster also, everything. Okay. So if you're able to see, still it is running. It will not impact while upgrading the cluster. Okay. So that is all about the storage namespaces cluster upgrade. Okay. So let's wind up for today. And tomorrow, if you have any questions, we'll go through it for Kubernetes. If not, we'll move on to the Jenkins topic.
Okay.
Let me make it Jenkins. So let's wind up for today. Let's catch up tomorrow.
Okay,
Bye
so
bye.
thanks.
Yeah, thanks. Bye bye.